In this video, I'm going to explain how to add and subtract fractions, both with common denominators and with different denominators. The important question for today is, how can fractions be added and subtracted? First, let's look at one simple example. Suppose we have these two wholes that are both broken up into eighths, and in them we have 1/8 and 2/8. If we want to add these two quantities, 1/8 plus 2/8, we can visualize a third box that's also broken up into eighths, and we can take that 1/8 piece and the 2/8 pieces and put them into that third box and see how much we've filled up. So it's pretty clear to see here that we're going to have 3/8. The important thing to notice is that while the numerators were added, 1 plus 2 equaling 3, the denominator didn't change. It stayed an 8 because it's just talking about the size of the piece. Let's look at another example here. We've got 2/7 plus 4/7. So once again, you can see that denominator is the same, so it's going to stay sevenths. The size of our piece isn't changing, and 2 plus 4 will give us 6/7. But now, what if the denominators are different? So for example, in this picture, we've got fourths and eighths, and the colored pieces are showing us 1/4 plus 3/8. So if we try to draw a hole with fourths and go ahead and fill in that one pink fourth, then if we want to get those blue eighths in there, we're going to have to break that down a little bit more to make them fit. Okay, so we can get those blue eighths in there. Okay, so now what fraction would represent this last image? Remember, the numerator is how many pieces we have. So we've got a pink and 3 blues, that's 4. But the denominator is supposed to tell us the size of the piece, and that's not the same throughout this picture. We've got some fourths and some eighths, so we're kind of stuck. This doesn't really make sense. What we need to do here is before we add, we have to get these fractions to have the same denominator, to be talking about the same size piece. If you look at this circle that's divided into fourths, you might notice that if we split those fourths into 2 pieces, we're going to end up with eighths. So then that pink part that was 1/4 can be written as 2/8. And now all of our pieces are the same size in this addition problem. We've got 2/8 and 3/8, and we can add those together and get 5/8. And also notice how that was represented on the fraction itself. We had 1/4, and then we multiplied both numerator and denominator by 2 to get 2/8. You might remember we talked about reducing fractions in a previous video. This is kind of like the opposite. We're getting the fraction into a less reduced form, but it's a form that's easier to work with for the purposes of this problem. And if you look at the visual representation, you can see how it's all connected. We divide our whole into eighths again, and you can see that pink becomes 2/8 added to the blue 3/8, giving us 5/8. Let's look at another example with unlike denominators. Here we've got 1/4 plus 1/6. So you might be wondering, how do you know what number to change the denominator to get that common denominator? The easiest way to do this is to find the least common multiple, or LCM, of those two denominators. If you want to know more about finding the least common multiple, you can look back to a previous video that I've made. But for now, we can just think about the multiples of 4 and 6. 4, 8, 12, 6, 12. We immediately hit on that LCM of 12. So we want to convert the fourths and the sixths into twelfths. Now that we've done that, we're ready to add. We've got 3/12 and 2/12, and now that we're talking about the same size pieces, we can add them and get 5/12. And remember, that denominator 12 is going to stay exactly as it is because it's just describing the size of the piece. Let's look at another example with unlike denominators and try to solve it without drawing a picture. So we've got 5/8 plus 3/10. So what is the least common multiple of 8 and 10 for our common denominator? It's 40. So we want to change our 8ths and our 10ths both to 40ths. And we're going to do that by multiplying 5 and 8, both by 5, and 3 and 10, both by 4. So that'll get us to 25 40ths and 12 40ths. Now we've got the common denominator, we're ready to add. 25 plus 12 is 37, and 40, of course, is going to stay 40 because it's describing the size of the piece. So we've got 37 40ths. And being able to find a common denominator here is much easier than trying to divide a picture up into 40 pieces. Lastly, we're going to talk about subtracting fractions. The process for subtracting fractions is no different than the process for adding fractions. We still need to have that common denominator because we need to have the same size pieces in order to be able to reasonably answer the question of how many are left when we take some away. So in this example, 11/13 minus 5/13, we've already got that common denominator, so we can just subtract the numerators. Now here's an example with unlike denominators, 6/12 minus 1/8. So we want to get 12 and 8 to a common denominator. The LCM of 12 and 8 is 24, so we can go ahead and multiply 6 and 12 by 2 and 1 and 8 by 3. Now that we've got that common denominator, we can go ahead and subtract the numerators. 12 minus 3 is 9, so we've got 9/24. And 9/24 can be reduced, since 9 and 24 have a common factor of 3. So if we divide numerator and denominator by 3, we're going to get 3/8. In the next video, we'll take a look at multiplying and dividing fractions. Thank you for watching, and I hope you enjoyed.